Try me. Come on.
How you going, guys? Curtis from Cutting Edge Engineering. So today's job is going to be a workshop upgrade for our Zayer milling machine. Ideally, I would be doing a little bit of work on my Frenner crane. We do have the RHS for the new boom section, but unfortunately the plates haven't arrived. So instead of that, we're going to do this. And the upgrade we're going to be doing is making a new drawbar bolt so we can feed coolant and air through the spindle. So the reason we're going to be doing this is a lot of the tooling that is available today has a through coolant feature. That feature is more designed for CNCs that already have through coolant hooked up to them, but these older and manual milling machines don't have that feature available. And there is a lot of tooling that I'm not using in the Zayer, like our cruz drills and our spade drills. They're designed to be run with through coolant so the inserts stay cold and they don't get damaged. So in order to utilize that feature and get longer service life out of our tooling, we're going to do this upgrade. So at the moment, the Zayer doesn't actually have a functioning coolant or air system on it. That is something I'm going to need to repair. So as you can hear, the coolant pump does actually start up and run, but there is something caught in the impeller, and the line that runs from the pump up to the head is actually broken. So what I've been doing is using a pump bottle with coolant or oil in it, or standing there with an air blower to blow the swarf out of the way while the machine's doing a job. But that does get quite annoying and very tedious, and it just makes a mess. And because we're starting to use this more and more, I really need to get this upgrade and repair completed. So the first thing I need to do is get the old drawbar bolt removed. So that's the bolt removed. It isn't the original bolt. This is something someone has made up using a piece of threaded rod. So now that that's out, we can get our measurements so we can make up our new one. So that bolt's 285mm long. It is 24mm in diameter with a 3mm thread pitch. Now that we know that, we can start making our new one. And to make our new bolt, we're going to be using a scrap piece of 2 banana 4140 chrome bar. So the first thing I'm going to do is set it up in the lathe so we can machine down the shank of the bolt, and then we'll thread it. So I've got that set up in the machine. I am going to be making the shank about 10mm longer than the original one, and the reason for that is that drawbar is actually a little bit short and I want a little bit more thread engagement down inside the tool holder. So I'm just going to zero out my X and Y axis and take our first roughing pass. I don't like that insert. So that insert just isn't chipping, so I'm going to swap it out for something that works. So we've got 23.63 mil of material to remove to bring this down to our finished size. So I'm going to rough it down to within half a mil, then change out to my finishing insert and finish at the size. So we've got our shank machine to size, now we can thread it. So I only need to thread about 25 mil, so I'm just going to move it back inside the chuck so I've got extra support. So I'm getting that to screw on all the way, but it is a little bit tight. So I'm just going to do a couple of spring passes and get that perfect. That's it. Righto, so that's the easy part done. Now we're going to get set up to do the hard bit. And what I need to do is drill an 8mm hole, 300mm deep. So the first thing I'm going to do is go in with an 8mm carbide drill. That's going to give me a nice starting point for the parabolic drill. So a parabolic drill has wider flutes to allow swarf to clear more easily, but they are brittle and very easily broken. So deep hole drilling is one of those things you need to take your time with. You can't get impatient with it. You let the drill do the cutting, you make sure everything's lubricated, and when you hear a pitch change in the machine or you feel that the drill is starting to bind, you need to make sure your drill is cleared, so you will need to take it in and out throughout the process in order to allow the swarf to clear. If you become impatient and start to push the drill, you're most likely going to break it and up scrapping the part and the drill. So we've successfully got that drilled to depth. Next thing I'm going to do is chamfer that hole, then we can turn it around and start machining the other end. Now that that's set up, I'm going to part it to length. So the overall length of the bolt is not too critical. As long as we've got enough material for the next process, it'll be fine. So now I need to machine this diameter down to 40 mil, but I am going to leave a shoulder on the bottom edge. So I've taken our clean-up pass. I've got about 9 mil of material to remove. So I'm going to rough that down and change to my finishing insert. So I've done my first finishing cut. I've still got about 0.2 of a mil to remove off the OD, but I am getting a few vibration issues, so I'm going to center drill the end, put the live center against it and finish it off. So I've got that machined perfectly to 40 mil. Now I need to reduce the top area down to 36 mil. So the length of this part isn't super critical, it just needs to be about 30 mil long. So the last thing I need to do on the lathe is machine in a groove 1.7 mil wide. So I'm going to change out my full form threading insert to a grooving insert. Righto, so that's all the lathe work completed. Now we're going to take it out and go set it up in the milling machine. So now we've got it set up in the milling machine. I've got it in a hex block and I'm going to use that for milling the hex on the end of the drawbar bolt. Now with that done, I need to drill a hole through the side of the bolt to meet up with the hole we drilled in the lathe. So that's the main body of the bolt completed. Those holes met up perfectly. Now we need to get this out of the mill and get the next part set up in the lathe. So what this part is going to be is the outer collar for the union joint. Because the bolt has to spin while the machine is in operation, this collar will stay still and allow coolant to be fed through it down through the drawbar. So the piece of material I'm going to be using is an off-cut of hollow bar. It is 65 OD by 41 ID. So the first thing I'm going to do is I'm going to face the end, do a clean up cut on the OD, and then we can bore the ID. So I've done a few cuts on the ID, which is going to give plenty of clearance around the drawbar bolt. Now I need to counter bore this end, so I've taken a measurement. I have 3.2 mil to come out. So now that that's done, I'm going to part it to length and we can do the same on the other side. So with that done, the last thing I need to do before I can assemble this is take it over to the milling machine. So that's our final part completed. Now we can assemble it.
Hurry, Jeffrey. Oh my goodness, aggressive. Okay, just calm down. George. Oh, that's it. See ya.
So that's our custom through coolant drawbar bolt completed. Everything went together really well, tight tolerances on the bearings, and everything moves freely. So that's definitely an upgrade from the threaded bit of rod I took out of the Zayer. I'm really happy with how that came out. So this only took a couple of hours to make. The material was basically scrap. We only had to spend $30 on bearings, and the seals were only $15. So it was definitely time and money well spent to upgrade our milling machine. So some of you might be wondering why I didn't just buy a rotary union joint that are designed to have liquid and air go through them, drill a hole through the drawbar and then fit it to the top of it. The reason why that's not an option is you do need to hit the top of the drawbar in order to eject the tool. No union joint likes being hit with a hammer, and removing the union joint every time you wanted to change out the tool would get very annoying. That is why I made this drawbar the way it is. So now we're going to go and test it in the mill. Righto guys, so that fits really well. I'm really happy with how everything works. It spins nice and freely. Next thing we need to do is test it with coolant.
Good point. Quit. Whoa. Good boy.
So off camera I did repair the coolant system. I did have to replace the pump. The impeller on the original pump was very damaged. It looked like a piece of swarf had gotten in there and it had chewed it up and it wasn't pumping coolant up through the column. So instead of trying to fix that, I was able to replace it and it only cost me $150. I've also cleaned out the coolant tank and put a new batch of coolant in it. I've also put a ball valve on the column so I can control the flow of coolant coming through the spindle, and I'll also replace the hose. So I've connected the hose up to our rotary union. Now we can test it out. Righto, so the coolant's working properly and it's running through the spindle without any dramas at all, but that's a bit boring, so I'm going to put in a tool that has a through coolant feature and show you what that looks like. So what we're setting up is a Pellet 140mm face cutter. It has a 45-degree approach and 8 inserts. So I haven't actually used this yet. I have been waiting to get the coolant set up, so I'm pretty excited to see how this looks.
Okay. Wow.
So that works spot on. I'm really happy with that result. Not only is it going to prolong the life of our tools, we are going to be able to take advantage of the through coolant feature. It's really going to be handy when we're using through coolant drills. Coolant does help clear swarf out of the hole, which will give it a much nicer surface finish and prolong the tool life. And to use air through this spindle, it's as easy as connecting an air line to the end of the coolant hose. So I haven't done this upgrade on our Bridgeport style milling machine yet because the drawbar is about 3 times as long as this one, and that would mean I would have to drill a 5mm hole about 1 meter deep, and I would have to have a step ladder beside the machine just so I could reach the top of the drawbar bolt to change out my tools. So there's a few things I need to think about before doing the upgrade on that one, but for now I'm really going to enjoy having it on this. It's just going to make doing jobs so much better. So that's this job completed. Thanks for watching.
You just want to angle it slightly somewhere. Like, whoa. Actually, you stay still.
Are you ready?
Yep.
I must start.
Oh my god.
You do need to allow that. Oh, fuck me, I've already lost it. So deep hole drilling is one of those things you... So it only cook. So that works spot... Oh, fuck. Oh, fuck me, now I'm having a brain moment. So there's actually a lot of stooling. Now that we've got that out, we're going to know the length of our new one.
What the hell was that?
So off camera, I did repair the coolant system. The fuck was that? But for now, help. Mate, shit. How'd you start it? It doesn't compute, hang on. Oh, it's bananas, that's why. And the piece of material we're going to be using, I don't even know what size it is.
What the hell? Where'd it go? What the hell? Whoa, Jesus, that's how they fly apart? Oh, fancy.
Yeah.
Wow.
Smoke.
What?
Come on, lassie, let's go. Smoke.
Oh, that's that ad from Family Guy. Yeah.
Smoke. Why aren't you smoking? Is that recording?
What is wrong with you? Anyone want a Curtis?
Well, fuck you, I'll have you.
Hey! That's gonna keep happening.
It won't, it'll be fine.
Okay. Is it on?
It's on.
What? It's not making any noise. Wow. That's amazing. Hello. Someone else.
There it is.
Hey. Hang on a minute. You're the greedy one.
No, you had some.
All gone. Really? He's like, don't video them, video me.